All right, so we have a big bouncy ball hitting the ground, traveling downwards, and then it bounces back upwards, and we want to know the contact force of the ball hits the ground. This is a classic impulse momentum problem. So we have the ball going down this way, and then it hits the ground, and then it bounces back up this way. So what we'll say is that here the initial is negative 10 meters per second, and here the final is plus 10 meters per second. And this time of contact is 0.02 seconds. So we want the contact force that the ball has with the ground. This is a straightforward problem. We have F times T is mv final minus mv initial. We have F times the 0.02 equals the half a kilogram, and V final is positive 10 meters per second minus 0.5 times V initial, which is negative 10 meters per second. And so we end up getting 0.5 times 10 plus 0.5 times 10. And when we solve, we end up getting 10 newtons worth of force. It's a typical impulse momentum problem. Now, for conservation of momentum, this is our setup. And what I'm going to do is just kind of draw the picture. So here's our astronaut moving to the right at 3 meters per second. So this is the astronaut. And then we have this asteroid moving to the left at negative 2 meters per second. And then they collide and come to a dead stop. So here's the idea. We have m1v1 initial plus m2v2 initial equals m1v1 final plus m2v2 final. Now, since they come to a stop, this momentum is 0 and that momentum is 0. And we want the mass of the asteroid, so we're going to have 70 kilograms for the astronaut times 3 plus m2, the mass of the asteroid, times its negative 2. So we're going to end up getting 210 is 2 times m2, and that gives us an asteroid mass of 105 kilograms. So that's actually the basics of how we do impulse momentum problems in physics. And when you come to class with these notes complete, we're going to go more in depth into how we use momentum and impulse in AP Physics.